Okay, ngayon naman ay i-discuss natin kung paano ang mag-add ng vectors gamit ang tinatawag na component method. Okay, dahil ito ay component method, na-discuss natin previously that a given vector have its x and y component, wherein the x component is the horizontal component of the vector and its y component is the vertical component of the vector. Now, we discussed in the vector resolution that we could get the components of the vector by using the SOHCAHTOA. And an easier computation of the components of the vector may be done when we measure the angle of the vector due x-axis. Now, if the angle is measured due x, then the x component of the vector Rx is equal to R cosine theta. Also, if the angle is measured along the x-axis, the y component Ry of a vector is computed by R sine theta. These equations are derived from the SOHCAHTOA, wherein cosine theta is equal to the adjacent side over the hypotenuse. Also, sine theta is equal to the opposite side over the hypotenuse. For example, we have one given vector that is oblique to the northeast direction. Okay, now, if that is our given vector, then what is its y and x components? The x component of this vector is the magnitude of the vector that lie along the x-axis. Okay, x component. And the y component of this vector is the magnitude of the vector that lies along the y-axis, y component. This is congruent to this side. Okay, now our angle is measured along the x-axis. Then this is our opposite side, which is also equal to the y component. And this is our adjacent side, which is equal to the x component, while the vector is the hypotenuse of the triangle. That's why we have this formula: Rx is equal to R cosine theta, Ry is equal to R sine theta. Always, this is applicable when the angle is measured due x-axis or the angle is measured along the x-axis. Now, example, we are to add three given vectors. We have vector A that has a magnitude of 20 meters. Therefore, it is a displacement vector and the direction is east. We also have vector B, which has a magnitude of 15 meters and its direction is 30 degrees east of north. While we have vector C, 47 meters. Direction is 40 degrees north of west. Okay, so let's first represent these vectors. Okay, so we have vector A is 20 meters east. Vector B is 15 meters 30 degrees east of north. Now, we notice the prepositional phrase of north. It means to say that we measure from north 30 degrees going east. So let's draw first our imaginary reference Cartesian plane. And our vector is 15 meters. So starting from north, you measure 30 degrees going east. Let's just approximate. Anyway, we are not doing the graphical method. Okay. So this now is 30 degrees. Now, we said that in order for us to make use of this formula, then we should measure our angle from the x-axis or from the east direction. With that, then this is 90 degrees. So 90 minus 30 is equivalent to 60 degrees. And 60 degrees is our theta x. Next, let's move on to vector C. Now, in vector C, the given is 47 meters. It's a displacement vector with a magnitude of 47 meters and the direction 40 degrees north of west. So starting from the west direction, we draw the arrow that is tilted 40 degrees going to the north direction. This now is our theta x, and our theta x is 40 degrees. Okay, so we had already represented the vectors. Now, let's write the measurement of the angle that is measured from the x-axis. Since this vector is lying on the east direction or along the x-axis, then this vector makes 0-degree angle with respect to the x-axis. Our second vector makes an angle of 60 degrees with respect to the x-axis, while our vector C makes an angle of 40 degrees with respect to the x-axis. Now we are ready to get the x and y components of the vectors. Okay, now the x components of the vector could be computed using this formula. Rx is equal to r cosine theta. That is when the angle is measured from the x-axis. Okay, so we have Ax is equal to A cosine theta, and that is equivalent to the magnitude of the vector is 20 meters, so 20 meters cosine 0. Okay, cosine 0 is equal to 1, and 20 meters times 1 is equal to 20 meters. Next, let's get the y component of vector A. Ay is equal to A sine theta. Substitute the values 20 meters sine 0 degrees. And using your calculator, you could confirm that sine 0 is equal to 0. Therefore, 20 meters sine 0 degrees is equal to 0 meters. using our Cartesian plane as a reference, a vector lying on the east direction takes positive sign in its x component. Okay, now let's proceed with vector b. Again, we use the formula bx is equal to b cosine theta x. Substituting the values, we have 15 meters cosine of 60 degrees. And cosine 60 is 0.5. So that now is 15 meters times 0.5. Multiply 0.5 times 15 and you will get 7.5 meters. Take note again that the vector is found along quadrant 1 of the Cartesian plane, wherein in quadrant 1, the x component is positive. Why? Because it lies along the positive x. So let's mark this one positive 7.5 meters. Let's compute for the y component of vector b. The y component of vector b could be computed using by is equal to b sine theta, and the angle must be measured along the x-axis. So, we use 60 degrees. Substituting now the values, we have 15 meters sine of 60 degrees, equivalent to 0.866. Let's round that off. That is 0.87. 15 meters times 0.87. And that is equivalent to 13.05 meters. Again, let's look into our vector. The vector is found along quadrant 1, wherein its y component lies along the positive y. Therefore, the y component of this vector takes positive sign. Now let's proceed to vector c. The x component again of vector c could be computed using the formula cx is equal to c cosine theta x. Let's substitute the values. We have 47 meters cosine 40 degrees. Cosine 40 degrees is equivalent to 0.77. 47 meters times 0.77, and that is equivalent to 36.19 meters. Let's look into our graph. The vector lies along quadrant 2, wherein its x component lies along the negative x. Therefore, the x component of this vector is negative. Let's continue by computing its y component. cy is equal to c sine theta x. 47 meters sine 40 degrees. Sine 40 degrees is equivalent to 0.64. 47 meters times 0.64, and that will give us a value of 30.08 meters. The y component of the vector lies along the positive y-axis. Therefore, the y component of the vector takes positive sign. To compute the resultant of the vector, let's first get the algebraic sum of the x components and the y components. Summation of x is equal to ax plus bx plus cx. 20 meters plus 7.5 meters minus 36.19 meters. Negative 8.69 meters. Summation of y is equal to ay plus by plus cy. And that will give us 0 meters plus 13.05 meters plus 30.08 meters. This will give us a sum equivalent to 43.13 meters. To get now for the resultant, we use our Pythagorean theorem. The resultant is equivalent to the square root of summation of x squared plus summation of y squared. Negative 8.69 meters squared plus 43.13 meters squared. So let's get first the square of negative 8.69 squared, and that is 75.52 meters squared. We also get the square of 43.13, 1860.20 meters squared. R equals 75.52 meters squared plus 1860.20 meters squared, and that is equivalent to 1935.72 meter squared. Let's extract the square root of that value. R is equal to 43.997 meters, or approximately 44 meters. How about the direction of the resultant vector? To get the direction of the resultant vector, then let's use tangent theta x is equal to y over x, or tangent theta x is equal to the summation of y over the summation of x. Tangent theta x is equal to 43.13 meters divided by negative 8.69 meters. Tangent theta x is equal to negative 4.96. Theta x now is equal to the arctangent of negative 4.96, and theta x is equal to negative 78.60 degrees. In the Cartesian plane, where is negative 78.60 degrees? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Starting from quadrant 1 and rotating counterclockwise, the measurement of the angle is positive. So this is 0, positive 90, positive 180, positive 270, and positive 360 degrees. Starting from quadrant 1 and rotating clockwise, then the measurement of the angle is negative. So this is 0, negative 90, negative 180, negative 270, and 360. So where is negative 78 degrees? So our negative 78 degrees is found right here, wherein the measurement of the angle from 0 is 78 degrees. The resultant now could be written as R is equal to 44 meters, 78.60 degrees. We started east going south, so that is 78.60 degrees south of east. Okay, so let's have a recap of the steps in doing the component method. First, you have to identify your vectors. Identify the given vectors, plot the given vectors so that you could visualize the directions of the vectors and the location of the vectors with respect to the Cartesian plane. Next, identify the angle the vector makes with respect to the x-axis. After that, solve for the components of the vectors using the formula x component is equal to rx equals r cosine theta. Y component equals ry, which is equal to r sine theta. After identifying the components of each vector, you get the algebraic sum of all the x component and all the y components. Get the resultant of the vector using the Pythagorean theorem. R is equal to the square root of summation of x squared plus summation of y squared. The direction of the resultant vector is computed using the tangent function. Tangent theta is equal to y over x, or tangent theta x is equal to y over